Hello, everyone. This class, we're going to continue with our computational methods in engineering. And specifically, we're going to introduce some formatting issues and also some requirements in MATLAB regarding the input or output. So if we do a quick recap of our last class we talked about the selection and repetition in MATLAB. I think in the future, if you're going to deal with larger data sets or if you want to do repetition calculation or iterations, actually these structures will be quite important. As you can see later on, we're going to involve some more examples so that you can practice with these selection and repetition applications. So regarding the selection, there is this else if, or else construct, or switch and case construct. So you can see that different types of construct can actually be used in different types of scenarios. And the switch case construct is better when you're trying to separate, let's say, decide different structures based on the texts, right? Based on the strings. While else if, or else construct is better when you're dealing with numerical values. And then regarding the repetition, we have the for loop, while loop. And in order to break from the loop, you could also use the break. Okay. So this is the recap of last class, and now we can talk about these new topics, input and output formats. So a lot of times, actually, we would like the user of our programs to input some values, right? Input values or input strings. Just recall last class when we were talking about inputting some values regarding the destination or regarding type of the unit we want the user to choose, right? So that's related to the input. So the input command, so here we're just talking about the input, not the function input yet, but the input command pauses the program and prompts the user for an input. And then regarding the output, so we could use display function, the formatted print function and table commands to provide the output in the command window. So right now we're talking about the command window, and actually we can use these in the functions as well. So one example can be, let's say that we're trying to ask let's say the user to input certain value, and in fact we could create a MATLAB file to include all of these practices, right? So let's say we define let's say not a function, but class 10, right? So let me save the file over here. And then we can do the first practice. If we want the user to input a value, we would just do z equals input. And then we enter a value here. So just as them prompt, right? So we could actually use any type of prompt. You use ChatGPT and use, let's say, the Copilot, right? There's always a prompt that let the user to input some certain values or certain strings. So this is the prompt. And then if you just run this function, so we already have a file that's named at class 10. Let's name it class 10 new. Okay. So then you can see that basically we're going to see this this line here, this prompt here, and then if you type in 10, right? So z equals 10. You can see it from here, right? This is a workspace. Let's further adjust this a little bit. Right, so this is z has a value of 10. And actually, you can also try to type in, let's say, a matrix, right? So let's do a matrix 1, 2, 3, 4, 5, 6, right? So you can see that z is now a matrix. Okay, you can try, let's say, using wrong type of data. Let's say you can do 3 elements in the first row and only 2 elements in the second row and see what you get. 1, 2, 3, 4, 5, and then it's going to say that the dimension is not consistent, right? So here we're specifically talking about a value here, but actually you can also put in a string if you want. So one more thing I wanted to mention is that basically here You can input the value, and then here we enter that. Basically, the prompt is enter a value, but you can actually put any text you want, right? So you can say put a value here, right? So if you run it, we have to put a value. Yeah. So let's say if you run it, and then you see that the prompt has changed to put a value here, right? Z equals 1. We just typed in, let's say, type in 1, 2, 3, 4. And then Z is 1, 2, 3, 4. So you can change whatever prompt you want to have over here. So it's not always, it's not like MATLAB knows what the meaning of the word you have over here. Okay. Another thing you can find is quite annoying is whenever we run this function and then the cursor is here. So how do we start from a new line? So to start from a new line, we can just put a backslash and n here. Okay. So basically, this is called a line feed, and line feed will create a new line, right? Start from a new line, and then you can put in the value. And you can put multiple line feeds. So if you want to give more space to the function, right? So this is starting from 2 lines from there, right? So this is a line feed. And remember that there is this slash and backslash. I think this is called the backslash. But then if you use the slash here, which is more like the ratio of 2 parameters, right? So then if you use slash here, actually it's not going to export, not going to be recognized as a line feed. So you have to use a backslash over here so that now you can, let's say, now you can see that it starts from a new line, right? So this is the backslash and starting from, and actually this backslash n can be used everywhere. So it's not only in this input function, it can be in the display function when you're trying to export some data from the, let's say the program that you created. So this is quite helpful if you want to start from a new line. So as I mentioned, the backslash command, right? This is the line feed. It commands MATLAB to start on new lines so that sequential outputs are on separate lines. So this is the example that it gives here. So you can see it's using the fprintf function. Okay, so we're going to talk about the fprintf, which is a formatted print function, right? So see how it's different from this display function, right? So be sure to use the backslash, not the correct flash or the front flash, right? So as I mentioned, we can also input strings here. So you can try, let's say we run it again, and then we just type in our name, right? Let me type in Yang, and then it's going to say that it was unrecognized function. So basically, we can also type in a Y here, or you can say that if you type in Y, it doesn't work, but if you type in, let's say Yang, and then it's going to get recognized, okay? So the reason is whenever you're trying to, let's say, type in a string, you have to use these quotation marks. So basically the quotation marks so that MATLAB recognize that this is actually a string. So if you don't have it, it's not going to recognize that because you see that here it's trying to recognize it as a function if you don't put the quotation mark. So that's why if you use this same command and try to type in the string, or ask a user to type in the string, you can see that it's quite cumbersome because they have to remember that you have to type in the string. But actually, you can specify what type of input you're talking about. So instead of using, let's say, this is the first practice, but let's just comment this thing here. So you could type in, put a string here and specify that this is actually a string. Okay, so now if you run it, you actually don't have to type in the quotation marks. So you can try, let's say, if I put the double quotation, I don't know what it's going to look like, but you can see that actually it's also recording this quotation mark here. Okay, so if I type in this quotation mark, but if you don't do that, just quickly move this bar away. Right, so if I run again and then just type in my name, and then you see that Z now is a string that contains 4 characters and doesn't have the quotation mark, right? So basically, we add this S here so that we can sort of specify what is the input the user should be putting in, right? So it's automatically going to recognize the input as a string. So it's not only a string, you can also type in, let's say, young one, right? So you can see the one here is also being recognized as a character instead of a number, right? Or numerical value. So now it's one is being converted because sometimes it makes sense because if you want to, let's say, put a date here, right? So then if you run it, you may say that today is September 17, right? 2025. And then you see the whole thing is being recognized as a string. So the number here doesn't make any meaning, right? It's not a value anymore. And you may say that, well, what if I want the value, right? What if I want to read the value of the 2025? So then you will have to further use some functions to split the string, right? And then to take out the numerical value and read it. Okay, so I think later on we might also will cover how to do that. Or you could also always go online and then Google, right? Try to see how to recognize the numbers from the strings. So then here is a practice, right? So we can try a practice and then let's say we try to create a function and then we want the user to input some parameters for a cylinder and calculate the volume of the cylinder. So how do we do that, right? So here I have the code here, but let's type in together. So we can do R equals input, right? And then we want to prompt the user to input certain value, right? So input, let's say first the radius of the cylinder. Enter the radius of the cylinder. And then remember the line feed. And the next is the height, right? Enter the height of the cylinder. Okay, so then we know that the volume is pi r squared. That's the area of the base and then multiply by height. So that's the volume. So then we can just do volume equals pi multiplied by r to the power of 2 multiplied by h. So here we actually put the dot calculation mainly because we want to avoid the problem of, let's say, people putting in multiple values, right? Because it could be that they're putting a matrix or it could be that even they're putting, let's say, putting an array or even a matrix. So we put the dot here just in case, right? People or the user used put in different types of the value. But if it's just a singular value, right, we call that as a scalar, then we can directly use this equation to calculate the v. Okay, so then this is our function, and then let's test it. So you can see the radius. Let's just try 1 in the beginning, and then the height, we'll try 2, right? So then it's going to be 2 pi, right? So you can guess the value, 6.28, right? So this is our volume. So this is a function, right? So then you may have the question, well, we calculate the V, but we don't want to always check the value from the workspace. What if we want to print it, right? What if we want to show that in the command window? So then you could use the different functions that I mentioned earlier, right? So there is this display function, the formatted print function, and the table function. So for this case, we can either use the display function or or formatted print function. So then you could do first again display some or to output some prompt or additional information from the program. So it can be the volume. You can do thank you for inputting the value, the volume of the cylinder is. And then under this situation, you might want to put in the line feed, right? Because you don't want the value to be attached to this sentence. So then display V. Okay, so this is our V here. So then you can try still do 1, 2, and then you see, thank you for putting the value. The volume of the cylinder is, let me see. So the display It looks like here it's not going to a new line. So let's try again. Okay, so it looks like the display function actually do not recognize this line feed. So let's try just run it in this way. Okay, so then, well, we may have the issue of how to include the line feed later on, right? So in that case, we have to probably have to use the formatted print function so that we can put in the line feed in the function. So just to make sure that I typed in the correct line feed. So it's not showing the right way. Then we try this again. Okay. So it looks like the display function doesn't recognize the line feed. So in that case, we'll just show everything in this way, right? So then basically the volume of the cylinder is here. And I think the reason why it doesn't recognize the line feed is because the display function probably already include the line feed in the function. So let's try this. And then we can display again. Okay, so now you see I basically created two separate lines or separate that sentence to these two lines. Okay, so then you see the display function actually embedded in line feed function. So if I put display, then you see that it's automatically in one line and then it has a line feed. So now it's the next line and then eventually it's a volume. Okay, so that's why it doesn't need a line feed symbol over there. Okay. So yeah, well, we already talked about the display function, right? So you see that this is actually quite straightforward. So you can just export or try to um, basically output any sentences, right? Any strings you want and any values you want. Okay, so here we're just displaying one specific value. So then the question could be, let's say, what if you want to include or display matrix or display arrays, right? So we can try over here that if we have a array of 1 to 5, right? And then if you want to display the x, right? So you see that this is how the x is being displayed. So you could also do, let's say, display additional sentences. For example, here shown as display the values in the x matrix are over here. Let me just copy everything so I don't need to type in. And then, yeah, it's similar to the previous example of the cylinder volume, right? So there is a line feed that's embedded in the display function. So you have this prompt here, and then you have the matrix. And then it could also be that we have a shorter value, right? Or even it could be a value, a single value of 0, okay? So then you have 0. Then sometimes it may be the case that you don't want to start from a new line. So then what we do? So we actually can combine the two display functions. So instead of directly showing the value here, we could use a function, this is already shown here, as the number to string function. So basically, we're trying to show the value of 0, right? So we know that x equals 0. So we want to show the value of x. So then for the display function, what it means is that inside the display function, everything has to be a string. But this number here is not a string. Remember, in the first few classes, we were talking about different formats of the variables in the MATLAB. There is string format, there's also character format, there's numerical, right? The number format, there's matrix format. So we have to convert this numerical format into strings. So you have to use the function of num to string, number to string, okay? And then put x over here. So to merge these two together, you will put this bracket here to combine them together, right? So then You could run it, and then you see that here you have the value in the X matrix are 0. And then it could also be a, let's say, a array, right? 1, 2, 3, 4, 5. And then you may also see that, well, here you have the column and then numbers directly attached to the column. So you can make these changes by just adding some spaces over here, because whatever you type in the string here, in this sentence here, is recognized as string, and the space is also a character, right? So these are automatically embedded inside. So it can also be 1.11 point something, right? So 1 point some random number, and then by what separate by 1. Okay, so let's try this. And then this is how it's going to show the values. Okay, so these are the values in the matrix, and then this is the sentence you want to display. Okay, so this is a number to string function that we can use in the display function. Okay, so number to string is actually quite useful whenever you want to show the show some certain values. So for example, it could be that you are creating some plots, right? So you also want to title the plots, right? So it could be, let's say, the title that includes a date, right? So we know that the date sometimes is involving the numbers, or let's say the trial numbers. We can do trial number being, let's say, 5, right? This is the 5th experiment, and then we're trying to make the plot of certain values, right? So we can do X being, let's just directly generate some random number, like 1, 5. Even do 1, 12, right? So then the number, basically we're creating an array that has 5 values, and each of the values a random number, right? So let's say that this is our plot. So you see, this is our plot. These are the random numbers. Let's just add some more symbols, use bigger markers here. This is a marker. Let's also connect the lines, right? So this is a table. And then you want to also name these figures, because, or you also want to include title to these figures, because after you save the figures, there's no way that you can recognize them, right? So then we know that we can include the title, but the thing is that the title has to be a string, right? So you can do actually a trial, and then you include number to string, and then try, right? So in this way, you combine these two together. So then these two separate parts together, right? So then you can create this function here. And then you see that the title is now embedded, because we know that to show the string, numerical values are not allowed. You have to convert the numerical value into a string value, right? So then you use the number to string function. So this actually can give us some pretty good, let's say, ideas, because, for example, you might have, let's say, up to 100 trials, and each of the trial you want to generate a plot, right? So you want to generate a plot and further compare them. We said that if you have 100 or even more of the calculation that has a similar structure, right? So these iteration type of calculation algorithms, then we want to use the for, right? So you can use a while or use the for loop. So for example, you can do for trial starting from 1, 1, 10, right? So under this situation, you don't need to define trial anymore, because trial starts from 1 automatically, and then you can do end, right? So then at the same time, you want to create a new figure whenever you run this this repetition structure. So what this means is that it's going to run through trial 1, 2, 3, 4, all the way to 10, and each of the trial you generate a similar plot, right? So we can, and each of the plot actually has a specific title. So you can run this, So it's generating 5 plots here. You can see one plot is trial 1, trial 2, trial 3, trial 4, trial 5, right? So then it's going to be easier for you to show multiple plots and then also change the title as you go. Okay. So this is about the function of the number to string function. And actually, I have to say that I use this function quite a lot whenever I try to, let's say, there's a need to show the title or to show the axis and everywhere. Okay, so we mentioned about the display, but actually you can see that for the display function, most of the time it can help with us, but then sometimes, for example, when you're trying to show the values in the matrix, you see that there's not a method for us to control how many digits you want to show in these values, right? It just exports whatever the default format of the numbers to be. So what if you want to show the values that has just one number after the decimal point, right? So one digit after the decimal point. Or what if you want to have more space before these values? Or what if you want to export some, let's say, some user-defined, let's say, strings, right? So under that situation, we will actually um, use the let's say the format print function, right? Fprintf. So let me just give a title to this section. This is display function. This function display. Okay. And then I'll also create another section. This is going to be fprint function for actually the reason why it's called fprintf is because this is a formatted print function. Okay, so what formatted print function means is that you could, let's say, still start from a single value. Let's say just name it as pi, right? So this is the pi, the specific value, and then you can do, let's say, f formatted printf the value of pi is, and then you could do let's say a percentage sign f, okay, and then x, okay, in this test. So another thing you might notice is that when we use the display function, we actually only show the value at the end. Theoretically, you could also combine the values and the sentences like how we use the brackets here. But then formatted display function allows you to specify a specific location. So this is sort of an identifier. The percentage sign is an identifier that it's going to relate this value to the x here. So then you may wonder, what does the f mean here? So f is the sort of the float number, right? Or is the fixed point notation. It's going to show you the most accurate, I would say the accurate representation of the, or format of the function. So now we can try this. So basically, let's display these two here and then run it, right? So as I mentioned, if you run again, right? So the value of pi is 3.141593 in this test. So you can see that this is sort of a longer format of the pi value. And one thing I forgot is that you have to use the line feed over here. So display function has the, let's say, display function has an embedded line feed. Right? But the fprintf does not. Embed line feed, right? So then if you try this function again, you can see that it's going to show the value of pi is 3.141593. So then it could be a scenario that, well, you don't want the pi value to be this long, right? So, I mean, before that, we can also compare what the display function does, right? So we can do display. All right, so we said we could do a similar thing, right? The value of pi is and then we set number to string, and then of X. And then we could do more in this test, right? So then we just add some space over here. And then you can see this is difference, right? So the first one is the formatted print function. It gives you a longer accuracy or higher accuracy, basically more numbers after the decimal point. And then the display function actually always give you 4 numbers after the decimal point. This is a default format, right? So display function, I would say, have fewer freedom when you're trying to show the values. Okay. But fprintf can actually do more. So what if, let's say, you want 10 numbers after the decimal point? So then what you do is you will put 10 in front of this f here. Okay, and also a dot. So the dot 10, so dot is sort of a separator, but then the 10 in front of the f specifies how many numbers you want after the decimal point. So let's try this again, right? So you can see that now it can be much more accurate. You can even do 100. I don't know if MATLAB is going to show you, but actually it is, right? So this is the sort of a more accurate or complete pi number, but you can see after certain digits, it's all 0 because it's MATLAB doesn't already, it's below its marginal error, right? It's below its machine error. So it's just going to report you 0. So now this is a way to control. And then you could also, let's say we control it to 2, basically 2 numbers after the decimal point. But then you could also, let's say, control how many spaces you want over here. So you could sort of keep a placeholder, say we can add 10 over here, right? So you can see the difference. The placeholder basically keep 10 places for the entire value. So you can try to count, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So including the 3.14, which occupy 4 spaces, right? So there are 6 spaces in front of it. So total value, the total number, the variable that you are showing has occupies 10 space. And then it's showing the basically 2 numbers after the decimal point. So now you can change it to 3 and see how it looks like, right? So now it's sort of aligned because you specify the total number of space this value is going to occupy. And then basically it's better formatted, right? So you also control how many numbers you want to show in this value. So as a matter of fact, there are different ways to show the value, right? So here it gives you an example of exporting how many cows are there in the garden. So we can directly copy what's over here and then see what we get. Okay, so the cow number is 5, and then formatted print function, there are this number of cows in the pasture, and then if you run it, you could probably already imagine it's actually going to give you a sort of a more accurate value of cows, right? So and we should include the line feed also. So now you have 5.000, 6 zeros after the decimal point. And then this sort of doesn't make sense to us because cows, we know that it's always an integer, right? So we don't want to show this many zeros after the decimal point. So then what do? We could try point 0, right? It's going to show you the 5. Or you can change the fixed point notation by just changing that to D. So D here is basically a decimal notation, but it's actually most widely used or more commonly used when you are trying to include when you're trying to export or output integers. So if you directly try this, and then it's going to show you 5 calls in the pasture, right? So I would say the F and D, these 2 formats are the most more commonly used formats. And then, of course, the string. If you are trying to export a string, you could also do that. So one thing you can try, for example, is let's say the date or the day equals Wednesday, right? So let me just start from a new line here. Day equals Wednesday, right? So then you can use the format print function of today is, and then use the notation, right? The percentage is sort of placeholder that you can basically control the formatted print function is going to recognize where to insert this value here. And then you could also do this because this is a sentence, right? And then put day over here. So now if you run, today is Wednesday, right? So theoretically, you could also do, let's say, occupy certain space, right? So it's going to do, let's say, 10 spaces because Wednesday is a little bit longer. You can try 15 spaces, right? So this is how we can control or how we can format our output, right? By using the fprintf function. So this is another example, right? So you can compare how does the placeholder, the percentage sign, and then the numbers in front of the percentage sign, especially for the F, right? The fixed point format. So then, for example, this is talking about the voltage you get from an electric circuit, right? The voltage is rarely having value of integer. So that's why here we should be using the fixed point format. And then as you can imagine here, it's going to give you 6 numbers after the decimal point. You can control how many basically how many numbers after the decimal point you want to input into the function, or we want to output, right? Want to output into the command window. So here 0.2 means that it's only going to give you 2 number after decimal point. So it's 50.50 and it's occupying 6 space. Then here is 6 space and then 4 numbers after the decimal point. 9 space, 4 numbers after the decimal point. And then if you use 0, it means that it's just going to depend on the value you put inside, right? So it's just basically right after the is here, it's going to show you the value and then include 4 numbers after the decimal point. So let's try this, right? So I will copy everything inside the function here and then can take a look. And then we can do a comparison, right? So the voltage is 3.500000. So as we said, if you don't put any control, then 6 numbers after the decimal point, right? So 6.2 means 2 number after the decimal point, and the whole number occupies 6 space. And then 6.4, right? So 9.4, 9 spaces, right? And 0.4, as I mentioned, it's going to be right after the is and the space, and only regulate the number of or basically the number of digits after the decimal point, right? Okay, so this is about the formatted print function and some hands-on activity, right? So basically percentage 8.2 specifies that there can be no less than 8 characters in the displayed output, and that the 2 of them are to follow the decimal point, right? So for example, if this is the weight, and then basically these can control the format. All right, so if you use 50.2F, then the whole thing, most of the space are going to be empty, and then you have the value here. So then, and what if, for example, if you want to show percentage, right? So it could be that you want to show a percentage. Let's say the yield is 3.5%. And then how do we show percentage? So you actually can use double percentile sign, the percentage sign, so that you can add a percentage sign. So what it means is that you can just add one more percentage sign here, right? And then it's going to be the voltage. Let's run it, right? So let's see. Okay, so you can try use 2 percentage sign to have a percentage. So then we can add it after. Okay, so it looks like that we have to use some other ways to show the percentage sign. Okay, so you could, for example, use a display function, right? Display function doesn't recognize the percentage sign. So if you do display and then just directly a percentage, right? It's going to export a percentage, right? So you could combine the formatted print function together with the percentage sign, but actually there should be a way to export the or output the percentage sign using the um, fprintf function. So we just quickly search. So show percent sign in fprintf. You must use a double percent sign within the format. Okay, so let's see. Percent double. This is a percent character. So then do we do double percent in front of F? Right, let's try. Oh yeah, right. So basically you put double percent sign and then a single percent sign for the value. So it can basically inside this string here, right? So we use double percent sign to represent a single percent sign, and then the single percent sign represents this identifier of the value, right? So now you can see the percent sign over here. Okay, so you don't have to use a display function. All right. So additional practice, for example, you can put in certain strings, certain values to show the birthday, right, or the date. So we said that we could use the string function, right? And then by showing that in the formatted print function, right, this day here, right? And then we could use the numerical value. So everything is exported as a string. So this is what you're going to get, right? So then there's actually another function called the sprintf, right? So sprintf, what it means is that it can actually save this print function or save this string as certain value. Okay, so for example, a lot of times we may have to type in some function and then show that as a title, right? So I think we sort of showed that earlier when we're trying to create this iteration to make the plots. But the idea is that we could save the longer string as a value, right? So basically, it could be this longer string is not only a certain, let's say, for example, only certain strings, certain character, but it's a combination of these strings and values, right? You could also format the value because earlier, remember, if we use the display, or let's say we tried that title, if you recall, title of the trial, and then number to string of the trial. I think we defined trial as 115, right? Remember earlier we had this definition, right? So then similarly, right? So when we try to show this value here, again, it's a combination. It's going to be similar to the display function. Everything, all the number are going to be under the default format, right? So what if you don't want it to be the default? What if you want to show that in a formatted string and then show that as a title, right? So we could actually use the sprintf. So, and then just use the sprintf to save that to a, let's say, title, right? So we can save the entire string as a title and then later use that, let's say, make a plot and then show the title as a title figure, right? So one example can be sprintf, and then we can do the same thing, trial number, okay? And then do s, or let's say let's do f, right? And then we can show, let's say, 2 digits after the decimal point, and then do trial. Okay, and then we define trial as 1 here. So basically here we specify that we want to show the trial. Instead of using trial, let's use flow rate. So then we can do flow rate. Let's just do Q, right? Q of certain value. Rate. So for example, we use 1 liter per minute of the flow rate, and then we want to specify what flow rate we're using, right? So we can even do Q equals, and then put LPM, right? So we have this identifier here to tell us where to put this value, but then at the same time, we want to add 2 numbers after the decimal point of 1. So then we can do run, let's say 1, 2, 5. Okay, so then we specify this string here. We sort of format it by using the sprintf, and we give this string to the title figure, this variable, and then we just show this figure title here. So then you can try this. So the plot random number should be 1, 5, right? So 1 row and 5 columns. So you can see we sort of formatted our string or of our title, right? So you can also, let's say, put 5 placeholder over there or spaces in between, and then try again, right? So then this is how the title going to look like, right? So you have more space, or you can even try longer. We can try 10, right? So if you use 10 here, type in, you see the difference, right? So basically the sprintf, when we normally use it whenever we're trying to create a formatted string and pass it to a variable, and then further we use that variable, right? So sprintf, this is where you can use it. So then the next is the table, right? So table is being used when we're trying to generate table with more information. So here, mostly it's going to basically show how to use this function. And then there can be different application. Remember earlier when we were trying to generate the conversion table of from one unit to another, right? So a lot of times we have to sort of provide these output and then generate the table, then can be read by others. So if you remember the table that we had at that time, we actually we don't have sort of the column number, right? We just have the table title, and then we have to rely on, for example, typing some text over there, and then to sort of identify what each column means. But actually, there's a way to export the data in the form of the table, right? So you can do that by using the table function. So here, this is trying to show you how to calculate the, let's say, this is the distance that can be traveled by an object under different gravity, right? So we know the distance is 0.5 multiplied by g, right? Acceleration, gravity, multiplied by time. This is over 100 seconds, right? We're testing 2 different planets, right? The Earth and the Moon. We can actually add more. If I recall correctly, the gravity of the Mars is 4.3, right? So then you can type in Mars, right? So basically the P here, the G and D, you can use whatever variable you want, right? And then the P here, this is the sort of the column title for the table. And then you can export everything by this table function. So let me just quickly put it here first, and then in the command window, you can type in, and actually these are the row numbers, right? So you have the G, this is a gravity because we show it in the format of the column, a single column, 3 rows, right? The D also have single column, 3 rows, and then the P here, this is sort of the row title. So you have the Earth, distance traveled, 100 seconds, Moon, and Mars, right? So then you see that, well, we also have these PG and Ds. These are the variable names, and we don't want to keep them as PG and D, right? So then the way you do it is you can basically add more options to this table. So you can specify the variable names. And then the planet, this is column title for the first column. G is the G acceleration and D is the distance. So let's try this command here. So you can put in, and now you can see that the column is over here. So then the next thing is, well, sometimes when we export the table, we don't necessarily want this answer equals 3 by 3 table. What if we just generate this table and that's it? So then you could actually use this display function again. So use the display function and then put everything, basically nest this table function in the display function. And then you can actually remove these answer equal to and also this 3 by 3 table, right? So then you have this entire displayed table here. Okay, so this is the table function, and then there are some other graphical input or output, right? Graphical output is more like making a plot, then, but you can also use graphical input to select the data from a figure. So here, for example, you define a function, right, and you make the plot, and then you could use the graphical input, the ginput, right, graphical input, and specify or to sort of select some data from your plot and then so that you can get, let's say, the X value or the Y value. So let's just quickly try this, right? So, well, before that, let me copy all of these code over here. So I'm gonna use these code later on. Okay, so this is f print f, this is f print f, and this is, let's say, print f. This is save the print function, printed string function. Then this is table function to display table. Okay, so the next section is, as we mentioned, this is the ginput, right? The graphical input, ginput function. So copy and paste over here, and then we can run this, right? So if you run, you're going to see this figure, right? Because we specify X is from 5 to 30, separate by 1, and then Y equals X squared minus 40X plus 400. And then it could be that sometimes if you have this plot here, you want to select certain value from the plot, right? So you can just press your cursor there and click, left click, and then it's going to give you the A and B value. This is the X value and the Y value, right? So X, A, and B. So then another thing is, what if you want to select 2 numbers or 5 numbers, right? 5 points. So then you just change the value over here. So let's say this is 5. Then you run it again. It can be 1, 2, 3, 4, and 5. Okay, so now it finished. Okay, so now if you show the A value is here, B value is here, right? And then the question is, if you don't have anything, and then what happens is that you will select the value until you hit the, let me see, until you hit enter. Okay, until you hit enter, then it's going to finish taking the data. So let's say you put it in here again, and then you select whatever number of points you want. It doesn't have to be on this line here, and literally can be anywhere, right? So as long as it is in this figure. And then to finish, you just click enter or type in enter, and then you can see the A and B value that we just selected. Okay, so basically this is the graphical input function. And then right now I'm just going to hide it over here so that we don't have any input requirements when we're trying to run our next section of the code. Okay, graphical input. And then the next, I would say quite important topic is about the importing from the files, because a lot of times it could be that we are offered with an Excel spreadsheet or even text file, right? So then the question is, how do we read the data from this file? So MATLAB can actually read quite a lot of different types of data files. Remember earlier when we did the example of letting the MATLAB playing a section of music, right? So we could actually control the frequency and the noise, right? Remember at that time we actually asked MATLAB to import a wave file, right? So Microsoft wave file, which is sort of a music audio data, right? So in addition to that, you can start from the basic text file. It turns out that .mat file is just a text file. And then the image data and audio data, even movie data. MATLAB can read movie data as well. But I would say most of the time, actually, we're going to use MATLAB to just read the text data or the spreadsheet data, Excel or the text file. Okay, so there are these typical data files that we are going to deal with. One is a binary. So binary is a machine language. It's fast and efficient, but it's not readily readable. You have to have some software to directly read these, right? So for example, XLS or XLSX, we know it's Excel, but if you don't have Excel installed in your computer, you can't read it, right? But for the ask-to number, so this ask-to format, this is more like a text file. So even, I mean, any computer that has basic uh, I would say installation should be able to read it, right? So it doesn't matter which computer you're using, Mac or Windows, it doesn't matter which program you installed, it can always read them, right? It can be read by any text editor, right? So Notepad in Windows, MATLAB, if you have it, good. If you don't have it, you can also read it. It's also good for sharing because these files normally have very simple format, right? It can be text file, can be .dat file, .csv file. So next time, if you see any of the data files like these, you can just open them by the text reader, right? The notepad in MATLAB in your computer in Windows and see what you get. But then for these XLS or doc, this is a Word file, as we know, right? .mat file, then these need pre-existing functions to read them, okay? So these are the different types of files, but let me just give you a quick example. So earlier from the examples of the homework and then sometimes in the class, I also show this Excel spreadsheet and then also showed in MATLAB, we could actually import the data, right? So you could import the data from the Excel spreadsheet and specify which rows to import and then save it as the .mat file, right? So then it could be that, well, these data format are not necessarily in the Excel format because you can't guarantee that each computer actually has this Excel format already involved, Excel programs already installed. So here is actually one example. So this is, I would say, a measurement campaign that was conducted earlier, I think in 2019, about aerosols or air quality. So the measurement was conducted in Eastern North Atlantic, over the Eastern North Atlantic. And you can see this is actually showing you the particle size distribution. You don't need to know what they specifically mean, but basically it's a bunch of concentrations at specific bin sizes. So you can see there are a lot of annotations, right? This is .txt file, which is a notepad file, right? You can directly open it by using like any notepad or the text programs on your computer. And then this is the data set. And you can see that one advantage for saving the data set as the .txt file is that actually it's very simple. It's directly readable, but the thing is that you can't really align them and separate them into, let's say, into tables, into, let's say, into a matrix, right? So then MATLAB actually offer you functions or methods to import these data and then further analyze them. So then one thing you can do is you can just import the data, right? So you can select this .txt file, and then automatically it is going to show you what these values inside the file mean. And actually, you can see that there are also text over here. And then this is basically data we want. It includes the time, the concentration at each size, and then in the end, you see this is ambient pressure, temperature, and then you can basically work with this entire data over here, right? So then you can select which rows to import because you don't have to import all of these annotations. You can just start from here, and then you could, and the way that it recognize or split the data is by using these delimiters to separate all the data set and then further include it in the, basically in the, let's see. Yeah, basically include them in the data set, right? So then you could select the numerical matrix again, and then you can select which rows or which columns you want to include, right? So then you can start from here and then end from, you can look for the last column, AH, right? AH, and then all the way to the end of 14004. Right? So now you selected everything that at least that's the data you want, right? So, or we want to analyze. So then that's, I think, yeah, this is the one we want, right? So then you can export, replace the number with not a number, and then you can export to the file here, right? So this is the .mat file or the matrix file, and then you can analyze the data. Okay, so then another thing is, well, a lot of times you see that, let's say if you have a PDF, right? So for example, from our textbook, you have these data looks like this. And then how do you convert that to a matrix, right? So you could actually just select these data, go to any MATLAB file, or not MATLAB, Excel file, and then copy, right? So you see, after you copy it, everything is in the same cell. It's recognizing it as a string, right? So then to extract the data or to convert these data into the actual data, string into data, then you could use this text to column format. So again, it's separate by delimiters, right? Delimited by comma, right? So if you select not comma, space, right? So this is a preview of the data, and then finish. This is what you get, right? So sometimes it may have a different format. So let's see, it should be a space in between. And this is how you can convert the text file or basically data from PDF and PDF into the MATLAB file, right? Into the Excel file. And further, you can work on the Excel with the MATLAB. Okay, so these are some scripts for us to basically read these files, and then you can also read and write the file. Okay, so there are some practice. So here, basically larger files and PDF files, you can use different tools to import them into Excel or MATLAB. So finally, is the code analyzer and the debugging. So normally when we type in the code, you will see that there are lines that give you some warnings or some errors, right? So this is a code analyzer automatically embedded over there. So it's going to let you know whether there are obvious errors. And then we talked about debugging sort of earlier in our class. So debugging basically try to find out the issues that are associated with your code. So we could use these stop signs to, or breakpoints, right? Or these stop points to analyze what's happening with our code. So the debugging basically is our primary task in our coding design, and it can help us a lot with identifying the errors. There are different errors. So due to the time limit, there are syntax errors, the way you type in the function. There are runtime errors. Basically, if you take the log value, it cannot be negative. Logical errors. A lot of times, you basically it's associated with the logic of these functions, right? For example, area should be side multiplied by side. It's not side plus side. So this is a summary. We talked about the input and output functions, and basically there are different ways for us to format the output, right? You could one important topic we discussed is the file reading and writing. It's going to be helpful if you're working with the data file that are not directly readable by MATLAB, right? You can convert the text file into Excel, Excel into MATLAB, or you can even use the text file by using the MATLAB default, let's say the file readers, right? And then the code analyzing and debugging. So that's it for this class. I hope you now have a better understanding of the input and output of the MATLAB, and let me know if you have any questions. Thank you.